And welcome to the Daily Space Weather. We've got an incoming coronal mass ejection impact likely, and all of your standard issue splentacular solar imagery, like this 24-hour video of ionized helium from SDO that you may have come to expect from the Smash News Network least busted name in news. And by the way, thanks for tuning in. Congratulations on realizing the existence of the channel. So you may see this huge plasma filament moving around down here in the southwestern limb. That is indeed the source of the incoming coronal mass ejection. We'll tell you all about it. Talk about sunspots and talk about lots more. Here's a closer view for you. Same deal. It is a 24-hour SDO video. And we do have a bunch of new named sunspots. Well, sunspots that will get names, I should say. We'll also talk about controversial carbon and lots more. Yeah, controversial carbon. You got to talk about controversial carbon, folks. Now, did you know that we built a massive infrastructure to create a sustainable operation here? Yeah, so we had to create our own website back in 2019, smashomash.com. And welcome to the Neo Renaissance. Please visit the links for additional content. Follow us on places like Twitter and Instagram and check out the Amazon shop. More on that in a minute. There is a paid promotion from our affiliates/sponsors. One of them is Hemp Lucid. So if you are shopping at Hemp Lucid, why not do it via our link or use the promo code SMASHOMASH to save some dough on your checkout. If you've never checked out the CBDs, I do occasionally use certain types of CBD products in limited situations. They are useful for various things, whether it's immune response, sleep, anti-inflammatory, of course, skin condition, as there are CBD body balms, lip balms as a protectant, CBD for your pets. Again, enter the promo code SMASHOMASH to save 10% on checkout, or just shop via the link provided below this video in the description and on the homepage at smashomash.com. You can also find links to the Amazon shop. Today's featured product is the purple-colored version of our air fryer. If you've never tried out an air fryer, why not pick one up based on our shopping list? Yeah, we've got a list of kitchen items, and one of those is the GoWise USA 3.7 quart programmable air fryer. Again, see the Instagram account for things about fitness, diet, etc. The shop is at amazon.com/shop/smashomash. Links below the video to that and on the homepage. Today's featured product is similar to what I'm actually wearing. I'm wearing the special edition one. That one is only available to gold annual paid-up Smash Team subscribers. However, it is the same basic design. Save 20% on your products. If you'd like a shirt that helps advertise the Smash Team, but you don't want to join the Smash Team at a 1-year annual gold paid-up subscription, which includes complimentary merch, the shirt that I'm wearing, you can also get a women's scoop neck shirt or a baseball hat featuring that basic logo. Again, it's slightly different color scheme and so on. Smashomash.com/Smash Team. That's the product of the day. Again, save 20% site-wide. Links below the video to the Redbubble shop. Links on the homepage to the Redbubble shop. One of the many pieces of infrastructure that we've created, a massive web ring has been created to increase the probability these videos will be sustainable, continue to exist, remain publicly visible, and free for all to view. Thanks to the Smash Team. These videos are brought to you in part by the Smash Team and at massive personal risk and expense by Smash staff and I. Again, save 20% site-wide. And if you want to support the channel and get some additional content via subscription services, become a member of the Smash Team at smashomash.com/Smash Team. In 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped the maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you certainly can. You are able to visit a website, I'm sure of it. Otherwise, you wouldn't be able to view this video, you spaced out type viewers. Now let's get back to space here and show what's going on with the closest star. So we'll start out here by showing some more SDO imagery here. This is the solar photosphere, the SDO continuum. It depicts sunspots. And while we don't have a lot of growth or decay of sunspots in the past, well, that's yesterday plus today to date, we will have a few more named groups that have just risen or formed around the eastern limb. So it'll be a minor uptick in sunspot number today. We've also seen an uptick in the radial flux, which we'll get to here momentarily. First, the colorized magnetogram. Again, no big changes happening, but sunspots rising and or forming around the eastern limb. More details on that momentarily. First, let's take a brief moment to see what's going on planet Earth. And Abico's erupting. There's a great view of the Abico caldera. If you are going on vacation, please do not pole vault volcanic calderae. That would be unhealthful, and it could reduce our views on YouTube, and we can't have that. So let's see what else is going on here in terms of volcanic eruptions. Again, Abico has been erupting, producing a 10,000-foot ash plume. It's a flight level 100. Flight level 080 over Sakurajima. It's an 8,000-foot ash plume. 6,000-foot ash plume over Subanose-jima. Mount Ibu exploding, flight level 070. Luitolo erupting, 7,000-foot ash plume there. Dakono exploding, 7,000-foot ash plume there over Halmahera, Indonesia. Popocatépetl exploding in central Mexico. No indication on the size of the volcanic ash plume. Please do not fly your hang glider. Or perhaps even don't fly your expensive drone over Popocatépetl. At least not through a volcanic ash cloud. Nevado de Ruiz, volcanic ash not observed. Don't assume it's not erupting. Sangay erupting in Ecuador, though, producing a 21,000-foot ash plume as it explodes. It's a flight level 210, flight level 240 over Sabancaya in Peru. It's exploding and producing a 24,000-foot plume of volcanic ash. As far as seismic activity, it's been pretty calm here for the past 24 hours. Not a lot of quakes over a 5 magnitude. We'll report quakes of a 5+ magnitude. A couple weird ones down here. These are some bizarre quakes very far south there. 5.8 near the Baleni Islands region and a 5.3 near Macquarie Island. We'll cover those in terms of when they happened and so on here in a minute. Also a quake at the shores of the Gulf of Mexico there, so that's interesting as well. Here are the quakes above a 5 magnitude, at 5 or higher magnitude. The Ryukyu Islands had a 5.0 at 10:32 Universal Time. That's not right. 22:10. 22:10 Universal Time. That's 10 after 10 p.m. Here's that quake west of Macquarie Island, very far south there, near the Antarctican/Australian plate boundary. That was at 0 dark 37 this morning. That was a 5.3 magnitude. And then to the southeast of that, this 5.8 was actually the largest quake of the past 24 hours there. That was at 2:45 Universal Time this morning on June 5th. And that's the extent of the 5 and larger magnitude earthquakes. Let's get back to space here and talk about controversial things. Yeah, controversial things. What's up with carbon? Yeah, carbon. I don't mean carbon dioxide. I mean ionized carbon. Carbon stripped of electrons, or stripped of some electrons at least, in ultra-hot temperature states there, right around the surface of the sun. You may see it getting bright over here. And, of course, it is controversial to suggest where that carbon comes from. So when you see this turning white, that indicates a lot of carbon in those areas. You can see carbon around active regions. So very low in carbon here, right at the sunspot umbra, and quite high in carbon here around active sunspots. Perhaps it tells us something about the physics, or perhaps even the internal workings of the sun. Maybe that's a little bit too controversial for you, so let's just move on to ionized iron, which this is totally not controversial at all, just ionized iron hanging out there. And let's just leave it at that. as far as the heliophysics goes. That's the past 24 hours. Also there, 171 angstroms, the house favorite wavelength. Again, we've got some new sunspots to get names over here around the eastern limb. So if you thought the sun was shutting down, you can just abandon that hypothesis entirely because it isn't happening. And let's switch to some additional solar data sets. The 10.7 centimeter radio flux now up to 168 solar flux units. Again, the sun is not shutting down. If somebody's been telling you the sun is shutting down, you may want to call them on that because see our channel for the last year for details. So there's actually been a big dip in the sunspot number showing up here on the 1 year graph. The black line there is the radio flux, and the red line is the sunspot number. So that's kind of weird. You see the sunspot number and radio flux actually diverging here. You can expect the sunspot number to start coming back up again today because there are some sunspot groups in the east that don't have names yet. Also, we do have a coronal mass ejection headed this way, and I don't think NOAA has noticed about it. So let's see. NOAA not forecasting any geomagnetic unrest or geomagnetic storm conditions. We are expecting a CME impact sometime around midday on June 7th. Yeah, Wednesday, June 7th, we're expecting a minor coronal mass ejection impact. I don't expect it to get above a KP 6.33 is my back of the napkin math estimate based on the trajectory of that coronal mass ejection. It's the huge filament eruption that we covered yesterday in great detail. And don't worry, we've got some additional imagery of it today for you as well. And as far as NOAA forecasting that, nothing doing. NASA forecasted it. NOAA does not have it striking in the model. I believe NOAA has it missing Earth to the west. So that's the Enlil spiral from the Space Weather Enthusiast dashboard. That is the the NOAA forecast for space weather. Here's a question for you. Did you ever put your pants on backwards and not discover it until you're in the middle of doing a live stream? I have. All right, now that I've remedied that situation, let's move on to some more data. Here's Earth's magnetic moment from space for the past 4 hours. And we're going to show you NASA's forecast here when we talk more about coronal mass ejections. At the moment, just the past 4 hours of magnetohydrodynamic pressure. We did get geomagnetic unrest for a brief period yesterday evening. We didn't even send out email alerts about that because it was a fleeting and nearly irrelevant uptick in the solar wind parameters. Here's Earth's magnetic moment from the ground for the past 4 hours. Again, we are back to geomagnetically calm conditions, and the coronal hole high-speed stream has been a complete dud. The solar wind speed only made it up into the 400s, I think. So kind of surprising there. Most of that plasma from the most recent coronal holes have largely missed Earth. So a little disappointing there, as there wasn't a lot going on, and there still isn't a lot going on. Again, it is a geomagnetically calm situation. And here's the KP index for the past 3 days. The planetary K index is a global average of geomagnetism. By the way, if you want to see more up-to-date data, check out the Boulder magnetometer. That's a good one. Let's see if we can find it here. There's the Boulder magnetometer. If you ever want to check that out, it's a little bit more timely. You can see little changes happening there to the magnetic fields at Boulder, Colorado. Anyway, again, the planetary K index currently at 1.33, and the solar wind here kind of weak. So we've got the coronal hole high-speed stream only made it to like 450 kilometers per second there, and only for a brief period of time. We saw a brief negative BZ there, but the field never got super strong either. The field only ever got to about 8 nanotesla, as you can see in that top pane there. The white line is the total field. The red line is the vertical component of the magnetic field. Anyway, current conditions are about 7 protons per cubic centimeter for the solar wind density, solar wind speed, 425 kilometers per second. GOES magnetometers here, not showing a lot of variation there. Again, it was a very weak coronal hole high-speed stream, surprisingly weak, despite fairly well-defined coronal holes. Perhaps the main one was too far south, and most of the plasma missed Earth to the south. Let's take a look at the heliospheric current sheet next. It's kind of important, and I would draw your attention once again, as we've been saying for days and indeed months, that this North Pole-oriented coronal hole is in the process of exiting the North Heliographic Polar region. And when that occurs, we can expect to see major upticks in sunspot, coronal hole, and geomagnetic activity. So we're just waiting on that fuse to get lit there. You can see it acting like it's going to snap down toward the equator at any moment. It could be the most important piece of data we have in forecasting when solar max will actually be. There's also a South Pole current sheet headed this way, as you can see there in the imagery. This is the South Pole heliospheric current sheet. Here's the North Pole current sheet. Earth should be in the South Pole current sheet in maybe 2 days. It all depends on sunspot activity, and it is of significant predictive value. The top view ecliptic plane field plot, part of the National Solar Observatory, the Gong 2 data. Next, our line of sight field plot, and you can see the sun's B field all fanned out here as Earth has just left the center part of the north magnetic pole of the solar system. This also depicts the Gong magnetogram in grayscale there, the line of sight field plot. And let's move to the coronal hole line of sight plot. Do we have any South Pole coronal holes popping through here? It looks like one opening up there. Nice. So right here you can see a little coronal hole rotating in here. Sector boundary crossing is now visible. Perhaps it might be right behind. It might be right in front of that South Pole coronal hole there. And let's take a look at coronal holes from the SDO's perspective. A little bit higher detail for you there. Again, we are really watching this North Pole coronal hole up here. These are all North Pole. And if we see one open, I don't think it's yet visible, as there is a lot of plasma. The solar corona is very bumpy, and the plasma has a tendency to obscure features. So somewhere down here in the southeast, there is a South Pole coronal hole, as that Gong 2 data will not lie to you. As many content creators on YouTube will absolutely lie to you, typically to line their own pockets with things like bunker supplies. Yeah, bunker supplies. Pretty pathetic, I know. Let's take a look at sunspots next. That's kind of important, I guess. Again, we've got multiple new groups to get names over here in especially the northeast. So also 3327 has been looking pretty active. That's the one in the southeast. And it looks like this flare monitor agrees with me. Oh, no, it thinks 3323 is more likely to produce large flares. Hey, no arguments there. Keep in mind, the magnetic fields of these sunspots can change quite rapidly. And let's take a look at them. There is the SDO magnetogram. And no rapid changes happening there recently. It's been stable for the past 24 hours, the time frame depicted in that clip. Here's SDO continuum for the same period of time. And I believe there are at least 2 new sunspot groups over here in the northeast to get named. We'll show high-res imagery of that before we move to our meteorology segment today. That's the past 24 hours in full animated SDO glory. And let's talk about energetic particles and solar flares. Solar energetic particle events are non-existent. There's the ghost proton flux. I don't even remember when we had the last proton event. It's been quite a while. And as far as flaring goes, the flare profile actually came up yesterday before midnight. Now it's dropping back down again, so it looks like a sort of a reduction here in solar activity, perhaps because of sunspots setting behind the western limb. The current background X-ray flux is about a C1.56, still much higher than it was a week ago. So if you go back to the 7-day, it was pretty high a week ago too. So anyway, the background flux is like a C1.5. There have been no major flares over the past 24 hours. And let's check and see what the most active regions have been. And let's go back to the ionized carbon here. So this is a great way to look at the most active regions as you look for the brightest places in 1600 angstroms. So yeah, it's maybe you're concerned that the sun is a source of global warming, climate change, or maybe even global cooling, depending on which school of, should I say, nonsense you come from. Anyway, here's a closer up view of that same wavelength. That's 1600 angstroms ionized carbon from the SDO. Again, you can see all those bright spots, especially this area down here. Lots of carbon showing up there. Let us know in the comments if you've got a hypothesis or maybe even a theory as to where all the carbon comes from. Was it just hanging out in the solar system? Does it just show up when flare activity happens for some reason all the way down at the surface of the sun? Or do you think maybe it's being created through nuclear fusion right there in plain sight, right out in the open? Maybe that's too controversial. Let's show some controversial clips. There you go. There is the northeastern limb, and you can see a bunch of whitening, because basically that's a carbon graph right there. That this imagery is like a carbonograph. It's the dark areas show no carbon, and the white areas show lots of carbon. And of course, here is the most carbon-rich portion of the Earth-facing portion of the solar disk. Great imagery there of some sunspots. By the way, that will be consistent with flaring activity as well. When you see lots of brightening in the 1600 angstroms, you'll see brightening in these wavelengths as well. That is what you see when you have solar flares happening. Keep in mind, this is not the X-ray spectrum. This is extreme ultraviolet, a lower frequency wavelength of light. That's 94 plus 131 angstroms. Two different species of ionized iron. So again, flaring has been pretty minimal. Here's the full disk view. Flaring has been pretty minimal since the past 24 hours. So maybe a little bit of underperforming sunspots there. Many of those are quite magnetically complex. And let's get back to some more information about what's going on from your space weather station, the Smash News Network. Least busted name in news. If you're out looking at the sky, you may see the summer triangle, which consists of Deneb, Vega, and Altair. Of course, it's not summertime yet, but you can still see those stars up there. Deneb as it just circles Polaris. Did you know that Deneb is the brightest object visible from our entire solar system? Yeah, it's the brightest intrinsic object. It's not the brightest star, that's Arcturus. However, it is the brightest object, intrinsically speaking. Could be important, I don't know. The only known point source for cosmic ray flux. I can't imagine why it would be important in any way. By the way, if you want to read all about Deneb, hit up smashomash.com/forum. There is a cosmology forum specifically, well, a thread in the forum specifically devoted to Cygnus X3 and Deneb, a high-mass X-ray binary in the Cygnus arm of the Milky Way galaxy. Yeah, you're part of the stellar sphere. You're part of Deneb's stellar sphere, since it is a known cosmic ray point source. It's been sending material through your brain if you live in the northern hemisphere for your entire life. Anyway, here's your solar system forecast. This is where things are today. Maybe that was controversial. I don't know. We're going to advance this 1 week. Here's where things will be on the 12th of June. We hope this month has been finding you well. Next, we're going to look at coronagraphs. And this imagery will include the Earth-directed CME that we started out talking about in the video. It comes out at around 11 o'clock Universal Time yesterday. It was happening right as we made yesterday's daily space weather video. And while most of that plasma will miss Earth to the west, there may be a minor glancing blow. Again, we don't expect more than about a KP 6.33. It all depends on the magnetic field orientation, plasma density, and speed. It's just basically a normal speed coronal mass ejection there. Nothing too special about it, but we are hoping to see some Earth strike for it because, hey, space weather, it's exciting unless it's boring. Those are yesterday's coronagraphs. And right here, you can see that CME coming out of the western limb. Expect that to arrive midday Universal Time on Wednesday, June 7th. So here are today's coronagraphs, 28 additional frames. And let's show NASA's forecast. So here's NASA's forecast. You're going to see this CME right there. And again, it's NASA is forecasting a glancing blow for that. So that's my guess, is that we'll see probably more like a KP5, a very minor geomagnetic storm. It may miss entirely, but that's the NASA forecast. And by the way, the NASA forecast is typically a little bit more consistent with our forecast than the NOAA forecast. Continuing on to show even more coronagraphs, there's LASCO C2 and C3. And I'll rock this back for you for a minute here. So here is yesterday. There you can see that CME coming out of the west, southwest. It's a little bit on the stealthy side. And this ejecta over here in the southeast, that is from a different event, we think. Again, minor CME impact expected here on the 7th. Here's the view from stereo A. We show this diagram so the people are aware that stereo A is no longer way over here at L5, but about to pass the Earth. And same deal with stereo B as it's orbiting this way. Stereo A is orbiting this way. And it's a bad time to attempt to calculate the trajectories of coronal mass ejections because of that close angular location of stereo A and B. Of course, stereo B lacks functional imaging equipment, so stereo B is no help anyway, no matter where it's located. Although it does have a magnetometer and other data sets like solar wind measurements. Anyway, that's stereo A and Soho LASCO C3. Let's let those play through here, just to show the maximum data that we can. Keep in mind those are not synced. Pay attention to the time and date stamps. So here's yesterday on the left, and you should see a CME coming out right there. You can see most of that ejecta is off to the west, and that the event in the southeast is a separate event, not likely to be earthly directed. So let's continue on here because it is time to talk filaments. And there are some massive filaments. Not as massive as this one that partially ejected yesterday that is now headed our way. But check out this huge crown prominence up here. Also below it, there's another huge filament right here in the Earth-facing portion of the solar disk. That one is likely to make an ejection. Also some large filaments down here. So lots of filaments. It's a great day for the likelihood of coronal mass ejections. And let's take a look at our favorite filament wavelengths. That's 304 plus 193 angstroms from SDO. So right at the beginning of the movie, you'll see that CME happening down here in the southwest. A lot of that plasma actually splashed back down toward the solar chromosphere. Some of it is headed a bit, maybe not directly towards you, but somewhat towards you. And of course, leave us a comment if you're viewing the videos from a separate solar system, galaxy, timeline, universe, multiverse, plane of existence, spaceship, star system, etc. Here's the past 24 hours in SDO 304 plus 193 angstroms. And you may see a lot of filaments. You can see some up here as well. So there is a lot of plasma currently suspended by the strong solar magnetic fields that are all over the Earth-facing portion of the solar disk. And we're not even at solar maximum yet. So expect another 1.5 to 2 years of similar levels of activity. We're super excited about it on the channel. Thanks to everybody who has viewed the content. Let's show some additional imagery here of plasma filaments in these same wavelengths. There's the southern hemisphere. You can see a lot of that plasma splashing back down. Just fantastic. And let's switch to the north. Huge filaments up there. And don't be surprised to see this one go flying, creating another solar polar vortex. That one definitely made the rounds across YouTube. Tamitha Skov, Scott McIntosh, and I think maybe even Dr. Keith Strong talked about it. So the possibility of that occurring again is kind of high there. If that crown prominence filament, which is this one up here, happens to detach, it could create some interesting plasma effects indeed. So there's the National Sunspot Observatory, ground-based Udaipur, India, Hydrogen Alpha Telescope. You can see all those filaments in perhaps a little greater contrast there. We'll also show the past about 2.5 hours there from the GOES 16 SUVI, and it looks like some flaring and perhaps CME activity is kicking off in the southeast. So that'll be a place to watch here throughout the day. We'll go back to streaming it on Twitch. And of course, if any other events happen, maybe we'll even put out another video for YouTube today. Again, that's the past about 2.5 hours from the GOES. It's the GOES 18 SUVI. I think I might have said GOES 16. The GOES 18, the new GOES satellite there, providing the ionized helium spectra. Which brings us to bonus features. Satellite charging hazards are non-existent. If you want to follow charging hazards yourself, head to the satellite's community dashboard, one of the many features of the NOAA Space Weather Prediction Center. GOES electron flux here is, well, cratered. That is typical of a coronal hole high-speed stream, even a weak one. And we've got a weak one, and we've got a cratered electron flux. Let's check out the forecast model after we look at the 1-year graph. There is the 1-year graph of the electron flux. We are in low levels of electron flux. And NOAA was pretty much spot on with the forecast. It looks like today's forecast will be quite close to being correct as well. No arguments there. And let's take a look at the layer of the atmosphere where that's measured. The F layer of the ionosphere. Feel free to pause the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with distances, chemical concentrations, electromagnetic radiation penetration, and temperatures of atmospheric layers. So here is the F layer in vibrational frequency. We are seeing some anomalies here. And if you're not recognizing them by looking at this imagery, don't worry. We show the anomalygram daily, which might be a little bit more definitive for you. Megahertz are millions of vibrations per second. The thermosphere has a lot of vibration going on. This is the layer of the ionosphere located at about 300 kilometers of altitude. This is anomaly from the 30-day median. More high-frequency anomalies north of the equator, low-frequency anomalies south of the equator. Keep in mind, winter is approaching for the southern hemisphere. Also keep in mind that the solstice is a time of the year when, well, we see less geomagnetic activity. It has to do with the angular nature of the solar plasma striking the Earth's magnetosphere. It's a lot more perpendicular around the equinoxes. So nothing too crazy going on in the ionosphere today, despite a coronal hole high-speed stream. There's the latest image, 11:15 Universal Time ionogram, and for some reason, 11:30 Universal Time anomalygram. I don't know why. Next, the total electron content forecast. It depicts free electrons all the way from the inner portion of the outer Van Allen belt to the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons cause signal refraction. And it tells us something about space weather. Yeah, a lot of times when your GPS is not working right, generally it's because of space weather. The total electron content will show you the most likely places to see those GPS errors. If you're expecting them, perhaps turn on Wi-Fi location accuracy. That can help, as the internet knows the locations of IP addresses. And we are seeing some anomalies down here. So this is a thing that we don't see super often, but down here we do see some total electron content anomalies. So check it out right there. You see those high electron regions down there, real far south near the Antarctican continent. And that's like a miniature Van Allen belt down there. That's a very high amount of electrons there in some very localized regions. So that does tell us some stuff about what's going on in space. And keep in mind, folks, if we actually saw a pole flip likely to be happening, we would see anomalies like this happening all the time, everywhere, all around the planet. We don't. And that's one of the many, many reasons why this channel does not think for a second that Earth's magnetic poles are about to flip. We think that's utter statistical nonsense. There is just as much evidence to suggest that they are as stable as ever. And keep in mind, polar excursions probably happen constantly. Yeah, the poles are probably always moving. We've only got, like, what, 150 years of solid data about that? And of course, keep in mind also, folks, that when you look really closely at a thing, you might discover stuff that wasn't even studied before. Like, I don't know, Neptune's weather? I mean, Neptune hasn't even been observed for one orbit around the sun yet, because it takes, like, I don't know, 140 years or something for Neptune to orbit the sun. Anyway, this is a total electron content anomaly from the 10-day average for North America. And things are looking pretty normal there. Let's close out the space weather section of the video with some high-res imagery of El Sol, Helios, the closest star. We've got a massive active region rising here. Not sure if that's a sunspot. Actually, it doesn't look like one so far. It looks like a plage. Nope, there is one sunspot there. So we've got multiple sunspot groups that ought to get named. Let's see. Here's 1. Here's 2. 3. Maybe 4. And also there may be a sunspot over here too. I forgot to bring this up earlier. There was one way down here. It looks like it has since evaporated. So that was there this morning. Not so much now. Anyway, here's your full disk view. So this group here is Beta Gamma Delta class, and this group here is Beta Gamma Delta class. Those are the two most likely places for solar flares. I doubt many folks will disagree with me on that one. And let's move to meteorology. The world is burning up, folks. It's burning up. I'm very spooked. It's like 113.6 degrees there, north of the Arabian Peninsula. So this is the hottest part of the world here. It's similarly hot northwest of India and so forth. This is the nullschool.net temperature. Some northeastern Africa is also kind of hot. The rest of the planet, nowhere near as hot as those areas. And as far as the coldest place, It's about negative 90 degrees Fahrenheit in portions of Antarctica. That's the hot and cold of it. And let's take a look at the winds. As we zoom in closer and closer to the lower 48, these are the jet streams. The heck? Oh, there we go. There are the jet streams of the eastern world. And here are the surface winds. Interesting wind ridge right here. This is a kind of a weird feature there. A surface wind ridge there in between, I don't know, in between some tiny islands in the Philippines. Is that Guam? I have no idea what those islands are. Here is the surface wind scenario for the west. Some odd wind ridges happening here in the North Atlantic as well. Here are the jet streams of the western world. We've still got a pretty incoherent jet stream over the U.S. Part of it is this large anticyclone here over central Canada. That's a high pressure zone. You can see the clockwise rotation of that system. That is an upper level high, which has been epically in place for several days here, and that is contributing to the incoherence of the jet stream over the U.S. Most of the jet stream there is missing the U.S. entirely. Here are the jet streams of Europe, Africa, and Central Asia, formerly known as the Middle East, now politically incorrect perhaps to say the words Middle and East together. It's very controversial, folks. Words are now violence, as it is 2023. And the propaganda has not stopped for the past 3 years. So hey, if you can't beat them, put out propaganda. Those are the surface winds of the central world. Many low pressures here south of Africa. Next, speaking of pressures, here is your pressure map. And it looks like the world's lowest pressure is indeed in the Southern Ocean there. It looks like this one is actually the lowest pressure. That is like a hurricane, although since it is so cold, there's not nearly as much convection. The Southern Ocean, featuring the world's lowest pressure. If you want to know where the world's highest pressure is, the world's highest pressure is on the Smash News Network, least busted name in news to not go out of existence. So once again, why don't you take a moment to press like, subscribe, share, comment, etc. That's okay, we'll wait. Have you done it yet? Have you joined the Smash team? Well, thanks to everybody who has. Here's the clouds and fog scenario over the Western world. So that's a satellite view. And if your favorite flat earther is asking for photographs of the Earth, well, there are some photographs. Keep in mind they are in infrared, so it wouldn't be visible to the human eye, even if you were up in space on the GOES satellite. And here's our weather.gov map. Now, we've got some coastal flooding here around Jersey and Delaware. Also Maryland. We've scrolled down to show you the key if your location is lit up on the map. Head to weather.gov and get your own weather warnings. Those are air quality alerts there over large portions of cheese country, Wisconsin. So here are some forecasts. This is the 250 millibar wind speeds, which is depicting the jet stream. And you can see the jet stream is going to remain rather incoherent here. It looks like it might be starting to form back up again. So you can expect another couple of days here with odd weather patterns. Like we said yesterday, if you're seeing weird weather patterns, guess what? It's not weather manipulation. Guess what? It's not HARP, geoengineering. It's not ScopeX. It's not chemtrails. Although contrails are pollution. Did you know that if in the northern hemisphere, if you live like a few miles north of an airport, You're probably experiencing slightly cooler highs and slightly warmer lows at nighttime because of clouds. Yeah, clouds. They block out the sun in the daytime, and they emit infrared radiation reflected from the troposphere at nighttime. In other words, clouds make it warmer at night and cooler in the daytime. Why? Because contrails are pollution. They just aren't geoengineering. They're in the troposphere. And anyway, let's just stop there. Here's your pressure and precipitation forecast for the 72-hour, the same model that we just showed. That jet stream model was the 72-hour GFS. This is a 72-hour GFS pressure and precipitation. And here is the 72-hour temperature anomaly forecast as we're getting cold air continuing to blow in the northeastern portion of the U.S. It's a bunch of cold Canadian air. Thanks a lot, Ricky, Julian, and Bubbles, for all the cold temperatures. I guess I don't really mind, but that's the GFS 72-hour temperature anomaly forecast in degrees Celsius. And let's take a look at lightning. Heavy lightning around Central America in the past about 10 hours. And you can see some storms moving in weird directions there. Like in northeast Texas, you can see a storm there moving to the northwest. That is not the normal path. And yeah, it's not caused by HARP, geoengineering, contrails, chemtrails, ScopeX. It's not caused by the Chinese building ground-based geoengineering facilities to burn chemicals on the Tibetan Plateau. And it's not produced by Bulgarians firing rockets at clouds to divert hailstorms from crops. It's none of those things. It's the jet stream being incoherent over the U.S. So here is our current lightning map, and lightning continues around the Mediterranean. Looks like heavy lightning in Spain there. Do we have any terrestrial strikes in the U.S.? We certainly have some in the Gulf and a minor thunderstorm happening there in north-central Kansas. I don't think anybody's being delivered to Oz on that one. Next time you hear thunder, check out lightningmaps.org. It could save your bacon. And here's the U.S. Doppler radar map. So there you go. There's vertical motion in the air column. Those are ground-based systems. And did you know that if Doppler radar systems are misused, they can heat up the atmosphere? Of course, you'd also be at risk of destroying the multi-$100,000 Doppler radar system by having it stop rotating, because it's going to heat up the atmosphere and itself if it's misused. This is a well-documented thing also, and not typically done, because you don't want to destroy your $300,000 Doppler radar system. Here is a satellite-based system, once again, depicting clouds and fog. You can see that cold air blowing over the Great Lakes from Canada. And here is water vapor. A second wave of dry mass of air there is sandwiching some moisture. So here's a great example, once again, of a blocking feature. You've got, this is a high-pressure system, relatively speaking. This is a low-pressure system, relatively speaking. And there's another high pressure there providing an impulse. So it's going to blow all of this system down to the south. This water is going to rather rapidly get mopped up through either precipitation or, well, most likely precipitation. But it's creating a compression in there. But a great example there of dry mass of air pushing the moist air around, because dry air at a given temperature and pressure is more massive than moist air. Also, hot air is less massive than cold air, hence hot air balloons floating. Anyway, here's your recap. Vertical motion in the air column. Clouds and fog. And water vapor. Hopefully that helps. Hopefully you're able to forecast your own weather when it comes to Earth weather or space weather. Thanks again for tuning in to the Smash News Network, least busted name and news. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, headed back to the bunker. In the meantime, may that solar wind be at your back. Bunker time! Bunker time! I'm going to be safe from all the scary, spooky stuff going on overhead, folks. Bye!